Various ways to access AWS services. When working with AWS, one of the first things you need to understand is how you can access and interact with AWS services. AWS is flexible by design, so it offers multiple access methods, each suited to different users, skill levels, and use cases. For the Cloud Practitioner exam, it's important to recognize what each access method is, who typically uses it, and when it makes the most sense. Let's walk through them from the most visual and manual to the most automated and advanced. First, AWS Management Console. The AWS Management Console is a web-based graphical interface that you access through a browser. This is often the first entry point into AWS for new users. It allows you to visually explore services, configure resources, and manage your account without writing any code. With the console, you can view dashboards that summarize services and account activity, provision and configure resources like EC2, S3, and RDS, monitor services and check resource status, manage billing and costs using tools like AWS Cost Explorer, access AWS from your phone using the AWS Console mobile app. Example: a beginner launches an EC2 instance by clicking through the Setup wizard, selecting an instance type, and configuring security groups visually. Exam tip: if the question mentions manual setup, browser-based access, visual interface, or learning AWS, the answer is AWS Management Console. Second, AWS Command Line Interface, AWS CLI. The AWS CLI is a command line tool that lets you interact with AWS services from a terminal. Instead of clicking, you issue commands that create, modify, or delete resources. This makes the CLI much more efficient for automation and repeatable tasks. Key advantages of the AWS CLI. Script repetitive operations. Perform bulk actions quickly. Use the same commands across Windows, Mac OS, and Linux. Integrate easily with automation and C/CD pipelines. Example: a system administrator uses a script to create multiple S3 buckets and apply consistent tags across environments. Exam tip: if you see automation, scripting, or command line access, think AWS CLI. Third, AWS Software Development Kits, AWS SDKs. AWS SDKs allow developers to access AWS services directly from application code. Instead of issuing CLI commands, developers write code in languages they already know, such as Python, Java, JavaScript, Node.js, .NET, Go, Ruby. The SDKs handle authentication, request signing, retries, and error handling automatically. Example: a Python application uses the AWS SDK to upload files to Amazon S3 whenever a user submits a form. Exam tip: if the scenario involves applications dynamically interacting with AWS services, the correct answer is AWS SDKs. Fourth, AWS Application, Programming Interfaces, APIs. At the foundation of all AWS access methods are AWS APIs. Every interaction with AWS, whether through the console, CLI, or SDK, ultimately results in an API call to an AWS service endpoint. Advanced users or specialized systems may call AWS APIs directly when they need very fine-grained control, custom integrations, capabilities not exposed in higher-level tools. Example: a custom monitoring system sends direct API requests to retrieve EC2 instance metadata. Exam tip: if the question mentions low-level access, direct service calls, or custom integrations? The answer is AWS APIs. Fifth, AWS Cloud Formation and Infrastructure as Code. IAC. AWS Cloud Formation represents a more modern and automated way of accessing AWS services. Instead of manually creating resources, you define your infrastructure in templates written in YAML or JSON. AWS then provisions everything automatically. This approach is known as Infrastructure as Code, IAC. Key benefits. Infrastructure is version controlled like software. Environments are consistent and repeatable. Fewer manual errors. Stronger governance and compliance. Example: a DevOps team uses CloudFormation templates to deploy identical environments for development, testing, and production. Exam tip: very important. If the question mentions repeatable deployments, templates, or infrastructure as code, the answer is AWS CloudFormation. Types of cloud deployment models. Before we dive deeper into how applications are built and operated in AWS, we need to understand where cloud infrastructure actually lives and how it's deployed. In cloud computing, this is defined by what we call cloud deployment models. A deployment model describes who owns the infrastructure, where it runs, and how it's accessed. For the AWS Certified Cloud Practitioner exam, understanding these models is essential because many questions test whether you can identify the correct model based on a real-world scenario. AWS primarily operates within three main cloud deployment models: public cloud, private cloud, hybrid cloud. Each model has different trade-offs in terms of cost, control, scalability, and responsibility. None of them are better in all situations. The right choice depends on business, technical, and regulatory needs. In the next slides, we'll look at each of these deployment models one by one, starting with the public cloud, then private cloud, and finally hybrid cloud, using clear examples to help you recognize them easily on the exam. Public cloud, explained. Let's start with the public cloud, which is the most common and widely used cloud deployment model, and the one most closely associated with AWS. In the public cloud model, cloud services are delivered over the public internet and run on infrastructure that is shared across many customers, also called tenants. Even though the underlying hardware is shared, each customer's data, applications, and configurations are logically isolated, so one customer cannot access another customer's environment. Shared infrastructure. In a public cloud, AWS owns, operates, and manages the entire physical infrastructure. This includes data centers, servers, storage systems, networking equipment, power, cooling, and physical security. As a customer, you don't need to worry about buying hardware, maintaining data centers, or replacing failed components. AWS handles all of that for you. Example: multiple companies run their applications on Amazon EC2, but each company's instances, networks, and data remain isolated through AWS virtualization and security controls. Pay-as-you-go pricing. One of the biggest advantages of the public cloud is the pay-as-you-go pricing model. Instead of making large upfront investments in hardware, you only pay for what you actually use, such as compute hours, storage consumed, or data transferred. Example: if a website experiences low traffic at night, it can scale down and reduce costs automatically, instead of paying for unused servers. Exam tip: if the question mentions no upfront costs, operational expense, or pay only for what you use, the public cloud model is a strong indicator. High availability and scalability. The public cloud also provides massive scalability and high availability. AWS operates a global infrastructure, with regions, availability zones, and edge locations around the world. This allows customers to scale resources up or down in minutes and deploy applications close to users for better performance. Example: an e-commerce application can scale automatically during a holiday sale and then scale back down when traffic decreases. Exam tip: if the scenario involves rapid scaling, global reach, or handling unpredictable demand, the public cloud is usually the correct answer. Public cloud in the AWS context. In AWS, most services operate under the public cloud model. Services like Amazon EC2, Amazon S3, AWS Lambda, Amazon RDS, all run on AWS managed, shared infrastructure, even though customers experience them as isolated environments. When public cloud is the best choice. The public cloud is best suited for web and mobile applications, general-purpose computing workloads, storage and backup solutions, startups and enterprises seeking flexibility and cost efficiency. It's especially attractive when organizations want to move fast, reduce operational overhead, and avoid managing physical infrastructure. To summarize, public cloud uses shared infrastructure. AWS manages the hardware and facilities. Customers pay only for what they use. It offers high scalability and global availability. For the AWS exam, when you see flexibility, scalability, and cost efficiency, think public cloud. Now let's talk about the private cloud. A private cloud is a cloud environment dedicated to a single organization. Unlike the public cloud, the underlying infrastructure is not shared with other customers. This gives organizations much more control, customization, and isolation over their systems. In a private cloud, the organization typically has dedicated resources, servers, storage, and networking that are reserved only for their workloads. Because of this, private clouds are often chosen by industries with strict regulatory, security, or compliance requirements, such as banking, healthcare, and government. One of the biggest advantages of a private cloud is enhanced security and control. Organizations can define very specific security configurations, network designs, and compliance controls that may be required by law or internal policy. However, this level of control comes with a trade-off. Private clouds are usually more expensive. The organization is responsible for purchasing or leasing hardware, maintaining infrastructure, handling upgrades, and managing operations. This means higher capital expenditure, CapEx, and more operational overhead compared to the public cloud. In the AWS context, AWS does not run traditional customer-owned private clouds inside its data centers. However, AWS does provide ways to achieve private cloud-like environments. For example, Amazon VPC gives customers logical isolation within the AWS public cloud, allowing you to design private networks with full control over IP ranges, routing, and security. AWS Outposts extends AWS infrastructure directly into your on-premises data center, enabling you to run AWS services locally while still using AWS tools, APIs, and management. So for the exam, remember this. A private cloud is about dedicated infrastructure, maximum control, higher cost, and is commonly used for regulated or sensitive workloads where isolation is critical. Now let's talk about the hybrid cloud model, which is extremely important for both the exam and real-world AWS use cases. A hybrid cloud combines on-premises infrastructure, often a private cloud or traditional data center, with public cloud services like AWS. Instead of choosing one or the other, organizations connect both environments and operate them together as a single, flexible system. The key idea here is interoperability. To make hybrid cloud work, organizations need secure and reliable connectivity between on-premises systems and AWS. This is commonly done using services like AWS Site-to-Site VPN or AWS Direct Connect, which provide encrypted and consistent network connections. One major benefit of the hybrid model is workload flexibility. Sensitive or regulated workloads, such as legacy databases or systems with strict data residency rules, can remain on-premises, while AWS is used for things like scalable analytics, backup and disaster recovery, burst capacity during peak demand, modern application development. This gives organizations choice and control. They don't have to migrate everything at once. Instead, they can modernize gradually, keeping what must stay local and moving what benefits most from cloud elasticity into AWS. From an AWS perspective, several services are designed specifically to support hybrid environments. AWS Storage Gateway allows on-premises applications to seamlessly use AWS Cloud Storage while keeping a local interface. AWS Outposts brings AWS managed hardware and services directly into your data center, so you can run AWS services on premises using the same APIs and tools. Amazon EKS Anywhere lets you run Kubernetes clusters on your own infrastructure while maintaining consistency with AWS managed Kubernetes in the cloud. For the exam, remember this clearly. Hybrid cloud equals on-premises plus AWS working together. This model is especially common for organizations with legacy systems, regulatory or data sovereignty requirements, disaster recovery strategies, gradual cloud migration plans. In short, hybrid cloud gives organizations the best of both worlds: the control of on-premises systems and the scalability, innovation, and cost benefits of AWS. When working with AWS, one of the most important practical decisions you'll make is how you interact with the platform. AWS gives you three main approaches: the Management Console, programmatic access, and infrastructure as code. The key is understanding that there's no single best option. The right choice depends on scale, frequency, risk, and purpose. Let's break this down using real-world scenarios. First, when to use the AWS Management Console. Think of the AWS Management Console as your visual control panel. You should choose the console when you are learning AWS or exploring a service for the first time. You need to quickly inspect something, like checking an EC2 instance status, reviewing logs, or validating a configuration. You're performing one-time or low-risk tasks, such as creating a test S3 bucket, updating a single IAM policy, reviewing billing and cost data. Real scenario. You're studying for the AWS exam and want to understand how security groups work. Using the console lets you visually see inbound and outbound rules and how they apply to resources. Key takeaway for the exam. The console is manual, visual, and easy, but it does not scale well and is not ideal for repeatable production work. Second, when to use programmatic access, CLI, SDKs, APIs. Programmatic access is the right choice when you need speed, automation, or logic. You should choose programmatic access when tasks are repetitive or need to run on a schedule. You manage many resources at once. AWS actions must be triggered from scripts or applications. Examples: using the AWS CLI to start or stop dozens of EC2 instances with one command, automate daily cleanup of unused resources. Using AWS SDKs inside applications too. Upload files to S3. Dynamically scale infrastructure. Generate pre-signed URLs. Real scenario. A DevOps engineer runs a nightly script that checks logs, scales resources, and sends alerts. Doing this manually in the console would be slow and error-prone. Programmatic access is the clear winner. Exam tip. If a question mentions automation, scripting, scheduled jobs, or application-driven actions, the answer usually points to CLI, SDKs, or APIs. Third, when to use infrastructure as code. IAC infrastructure as code is the most mature and production-ready approach. You should choose IAC when you need consistent environments, dev, test, prod. Infrastructure must be repeatable, auditable, and version-controlled. You want to reduce human error and enforce governance. With AWS Cloud Formation, you define infrastructure in templates instead of clicking buttons. Real scenarios. Rebuilding an entire application stack in a new region for disaster recovery. Deploying identical environments for multiple teams. Passing compliance audits that require traceable infrastructure changes. Why IAC matters. If your infrastructure exists as code, you can store it in Git, review changes before deployment, roll back safely, recreate environments at any time. Exam tip. If a question emphasizes consistency, repeatability, compliance, or multi-account environments, IAC is almost always the correct answer. Here's a simple decision framework you can memorize for the AWS exam. Learning, exploration, one-time tasks. Think about AWS Management Console. Automation, scripts, operational tasks. Think about CLI, SDKs. Production, compliance, repeatability. Think about infrastructure as code. In real AWS environments, teams often use all three together: console for visibility, CLI for operations, IAC for deployments. Understanding when and why to use each is exactly what AWS expects from a cloud practitioner.
Thank you for watching. See you in the next class.